Okay, we are done with this. So we'll do now these problems. So we'll do 100. What's the idea in this question? He wants us to find the second derivative. So we'll do the find the first, then find the second. That's it. X squared plus 3x minus 3, where it's very difficult to find a pattern. Huh? So just we'll do the calculations. So it will be f prime. It will be 2x minus 9x minus 4. What will be f double prime? It will be 2 plus 36 x minus 5. In other words, this is 2 plus 6 over x to the power 5. Now we'll do 102. What will be f prime? Just a product rule, a quotient rule. Derivative of the denominator of the numerator, 2x plus 3 times the denominator. The denominator, which is 1 times the numerator, all over x minus 4 squared. In other words, this is what? This is 2x squared minus 5x, 3x minus 8x, which is minus 5x, minus 12 minus x squared minus 3x over x minus 4 squared. In other words, this is what? X squared minus 8x minus 12 over x squared minus 8x plus 16, or I can write it x squared minus 8x minus 12 over x minus 4 squared. I will play with this denominator. Sometimes I'll use this, sometimes I'll use this. It depends on the calculation. F double prime will be what? The derivative of the numerator, which is 2x minus 8, times the denominator. Now we'll use the derivative of this, which is the same. So it will be 2x minus 8 times the numerator over the denominator, the power 4 square. Now I notice in this, I can take it as a common factor, 2x minus 4, the remaining, which is x squared minus 8x plus 16, minus x squared plus 8x plus 12, all over x minus 4 to the power 4. Oh, I can cancel. This is 3 and this is 1 off. And this one, I have x squared cancelled, minus 8x cancelled. So I'm getting what? 2 times 28 over x minus 4 to the power 3. In other words, it's 56 over x minus 4 to the power 3. Okay. Now let me do 104 here. What will be f prime? That will be derivative of x, which is cosine x, minus x sine x. F double prime will be equal minus sine x. Product rule here, I have minus sine x minus x cosine x, and that equal minus 2 sine x minus x cosine x. 107. This is will be what? Quotient rule. So G prime derivative of the numerator, which is ax times denominator. Derivative of the denominator, which is ax times 1 over x squared. And in other words, this is what? Yeah, that's it. This is G prime. G double prime will be what? Derivative of the numerator, which is what? I have product rule here. So I have AX plus X AX minus AX, all of this times X squared minus 2X EX X minus EX over X to the power 4. And that will be what? This is cancelled. So I have X cubed AX minus 2X squared AX plus 2X AX over X to the power 4. I can take X common factor from the numerator. And the remaining, I can take X and EX also, actually. X and EX are common factor. The remaining is what? X squared minus 2X plus 2. All over X to the power. This is cancelled. I have 3. This is cancelled. So I have a to the power X over X cubed times X squared minus 2X plus 2. Okay. Now, this is also about the higher derivative. He says they have, they think the fourth derivative is minus sine x, 1, 1, 1. No, this is the second derivative. Second derivative, 1, 1, 1. Second derivative is minus sine x, and they want what is the eighth derivative. Okay, now I know for sine and cosine, that every 4 derivatives will be the same. So plus 2 plus 4, it will be the 6th derivative is minus sine x. خلاص. So it will be the 7th is minus cosine x. And the 8th is sine x. Okay. 1, 1, 2, which is easier. They said the 4th derivative is t cosine t. What will be the 5th? The 5th, which is the derivative of the 4th. So I just need to find the derivative of this, which is cosine t minus t sine t. That's it. Okay. These problems, 115 and 116, he gave you some information about a function called g and another function called h. He wanted to find the derivative of f and the derivative, which is g over h. Just use this information, and the same thing for 116. 115, I know f prime is g prime, yeah, times h minus h times g prime minus h prime times g over h squared. So what he want? He want f prime at 2. So f prime at 2 will be g prime at 2, h at 2, minus h prime at 2, g at 2, over h at 2 squared. Then I use the information. What will be g prime at 2? G prime at 2, it will be minus 2. H at 2 is minus 1. G prime at h prime at 2 is 4. G at 2 will be 3 over h at 2, which is minus 1 square. So what I have 2 minus 12 over 1, which is minus 10. 116, which I think it will be easier. What will be f prime? Product. So it will be derivative of the first times the second plus the first times derivative of the second. So f prime at 2 will be g prime at 2. Let me write it. Okay, g prime at 2, h at 2 plus g at 2, h prime at 2. And that is what? G prime at 2 is minus 2 times h at 2. H at 2 is minus 1 plus g at 2, which is 3, h prime at 2, which is 4. So it will be 2 plus 12, which is 14. Okay. Higher order derivatives, polynomials of which degree satisfies this? We know that if fx equal x to the power n, then the n derivative is 1.7. Then the n derivative is 0. No, the n derivative is n factorial. But the next derivative is 0. So he's saying, what are the polynomials where the n derivative equals 0? So it means the n plus 1 derivative equals 0 if I have x to the power n or lower. So this will be equal to 0 for polynomials of degree n minus 1 or lower. Okay, look, if I have the n plus 1, I want the n derivative. So I want this to be x to the power n minus 1 to be 0. I have x to the power n minus 1 or lower. Huh? Since if I have f of x, x to the power n minus 1, what will be the n derivative? Look, it's more by 1. So that will be 0. If it is x to the power n minus 2 or less, for sure it will be also 0. Because of 0, 0, 0, 0. Okay. 118. He's saying you have this function, which I can write it as what? X of minus x, if x is less than 0, x of x, if x is greater than 0. Let me make the equality here. Yes. Minus x squared, if x is less than 0, x squared, if x greater than 0. Okay, now he wants us to find what? He wants us use this approach, differentiate piecewise. Y f double prime, so I need to find f double prime. So what will be f prime? It will be minus 2x as x less than 0, 2x if x greater than 0. Do you have equality at 0? Yes, that will be 0, that will be 0. So I'll make the equality here or there, no problem. What about f double prime? Minus 2 if x is negative, 2 if x is positive. But f double prime at 0 does not exist. Why? Because f double prime plus at 0 does not equal f double prime minus at 0. This is 2 and this is minus. This is f double prime negative at 0 and this is f double prime positive at 0. Like what we did with these piecewise functions. Okay, we are almost there. Now we want to sketch a graph and some information. Can we sketch a graph? Yeah, just want to sketch a graph, not a complete solution. Sketch. It says sketch means just a sketch. Huh? I have a function So that f of 2 equals 0, 1, 2, 3. We want to graph a function. F of 2 equals 0. And f prime is negative for this period. What's the meaning of this? Means the slope of the tangent is negative. So the function will do something like this, where the slope is always negative. I hope it's clear. Now, and for any value less than 2. For the value greater than 2, it will be positive, so it will be the other way. So I have the slope of the tangent always what? Positive. Okay. Which is decreasing and increasing somehow, which is we will do in chapter 4. Then 124, since the graph function f, so that f is positive, the function is always positive, but f prime is negative for all real numbers. Okay. 124. We want to sketch a function which is always positive, so the function is always above the x-axis, but the slope of the tangent is decreasing, so it's or it's negative. So we'll do something like this. For sure, the slope of the tangent is always negative, and the function is always above the x-axis. So that will be my graph. 125, what they want, he gave you v at t. This is v at t. This is the velocity. Find the velocity and acceleration of the object when t equals 3. V at 3, just substitute 36 minus 9, and that will be 27. That will be 27. A at t is b prime at t, and that will be minus 2t. So it will be a at 3. A at 3 will be minus 6. Okay. It will be minus 6. When they have different, this value, opposite signs, then the acceleration and the velocity, they have opposite signs, they call it the speed is decreasing. Speed is decreasing. Speed is decreasing. Okay. Find the pattern. Okay. We want to find the end derivative for this. Now we did it, and we know the end derivative, it will be what? N factorial. We did it for x to the power 4, if you remember in the class, where we show, yeah, we can show into the fourth derivative is 4 factorial. Okay. Now let me do the other one. The other one needs a little bit of calculation. F prime of x will be what? F prime of x will be quotient rule. You see in the bottom. F prime will be what? Derivative of the numerator, which is 0 times x, so it will be minus derivative of x by minus 1 over x squared. Okay. Second derivative, it will be minus 1 times 2x over x cubed. And that will be 2 over x to the power 4, I mean. 2 over x cubed. So this is x squared square, huh? This is x squared square. Third derivative will be 2 minus 2 with 3x squared over x to the power 6. In other words, it's minus 2 times 3 over x to the power 4. I think it's very clear we're heading towards what. Let me do the fourth one. to see it. It will be minus 2 minus 2 v3 v4 x cubed over x to the power 8. And that give me 2, 3, 4 over x to the power 5. Okay, now let me make this is what? 2 factorial over x cubed. This is minus 3 factorial over x to the power 4. And this one, 4 factorial of x to the power 5. Okay, can I think of the end derivative? Will be what? Look, first, just think about the denominator. First, x squared. Second, x cubed. Third, x to the power 4. So for sure, this will be x to the power n plus 1. Third, x to the power 4. Fourth, x to the power 5, and so on. So then derivative over x to the power n plus 1. Okay, here I have 1 factorial. This is minus 1 factorial over x squared. I will deal just with the number, then I will deal with the sign. So 1 factorial, 2 factorial, 3 factorial, 4 factorial. The first, 1 factorial. Second, 2 factorial. Third factorial. So I have n factorial. Now the sign I have with the odd numbers, f prime is minus, f double prime positive, third negative, and so on. So I can write it minus 1 to the power n. Where if n is odd, I'm getting a negative, like the 1 and the third. If n is even, I'm getting positive, like the second and the fourth. So this is the n derivative. Differential equations, where we want, I think this will be, we're almost at the end. I want to, he said, verify that the function satisfies this differential equation. So what I will do, I will find y prime, which is x to the power minus 1. So this will be, you know what? This one, if we do it with y equal x to the power minus 1, I think it will be easier. Let me check. Y equal x minus 1, y prime minus x is minus 2, y double 2 x to the power minus 3, y triple 2 في minus 3 x to the power minus 4 y to the fourth equal to في minus 3 minus 4 x to the power minus 5. So this will be easier to, instead of doing all of this, to see these things. Okay, so I'll find y prime. It will be minus x is minus 2, y double prime 2x is minus 3. I want to plug it here. I want to check into x cubed, y second derivative plus 2x squared, y double prime, y prime. This is the left-hand side. I want to check the left-hand side equal the right-hand side. So do the calculation. I have x cubed times this plus 2x squared times this. That will be what? 2. This is minus 2, which is 0, which is the right-hand side. So this is correct. 136, the same idea, but a little bit calculation. Y equal what? And also you want the third derivative. Y equal 2x cubed minus 6x plus 10. So y prime is what? 6x squared minus 6. Y double prime, 12x. Y triple, 12. Check left-hand side. Same idea. Equal minus y triple minus xy prime minus 2y prime. That will be equal to what? Minus 12. X في y double prime minus 12x squared minus 2y prime minus 12x squared plus 12 minus 2 plus 12. That should be equal to what? خلاص, this is cancelled, which is minus 24x squared, which is the right-hand side. That's it. So this is correct for this function. Okay. True or false? True or false? Yeah. Then I will try to do these two in the next page. Okay. If y equal f of x g of x, then dy over dx equal this, which is wrong, very clear wrong. This is the formula. So this is wrong. If y equal 140, okay, if y equal x plus 1 times x plus 2 times x to the power plus 3 plus, this is means y is what? Y is a polynomial of degree what? 1, 1, 1 of degree 4. So it will be the fifth derivative of this will be 0. So this is correct. This is correct. Okay, 141. We said if f prime at c and g prime at c are 0, and h of x equal this, what will be h prime at c? H of x equal f of x, g of x. What will be h prime? F prime times g plus f times g prime. So h prime at c will be equal what? F prime at c, g at c, plus f at c, g prime at c. This is 0. This is 0. So 0 by any number plus a number times 0, which is the result is 0. So this is also correct. 142 of the position function of an object is linear. Position s of t, 142. S of t is a linear function. What's the meaning of linear function? Ax plus b. Then its acceleration is 0. Yes, since v of t is a, and what is a of t? 0. This is the acceleration. 143, the second derivative is the rate of change of the first derivative, which is the derivative of the derivative, which is the second derivative. So this is correct. This function, 144, f of x sine x plus c. We know what will be the first derivative? Cosine second minus sine third. Third is minus cosine. Fourth is what? Sine. Fifth is cosine. Look, the fifth comes to the first. And I know every 4 times it will repeat itself. It will repeat itself. Because of that, you wrote the end derivative is equal to the end derivative plus 4. Because each 4, so this is also correct. Now, this is the last things. I want to find the derivative as a rule of f of x, g of x, h of x. One idea, you can deal with this as one function. So say this will be the derivative of this. So this is the first, and this is the second, times the second, plus the first as a bulk, times derivative of the second. Now I will do the product rule again. This is 145. So that will be the derivative of the first times the second, plus the first times derivative of the second. All of this times h of x, plus f of x, g of x, h prime of x. Now do the calculation. That will be f prime times g times h plus f times g times h plus f times g times h prime. Notice the derivative goes from f to g to h. Last one, 146. He says, yeah, part A, f G prime minus F prime G prime. I have product here. So that will be F prime derivative of the first times the second minus F the second, the derivative of the second, the derivative of G prime, which is G double prime, minus. Now this is the derivative of the first, which is F double prime times G. Okay. Minus, well, plus, what is plus? This is plus, not minus, product rule. Plus F prime G prime. In other words, this is F prime G prime plus F G double prime minus F double prime G minus F prime G prime. This is cancelled. So I have F G double prime minus F double prime G, which means this one is correct. Second one, B, FG double prime. I need to do it in steps. Huh? Call H as FG. What will be H prime? It will be F prime G plus G F prime plus G prime F. What will be H double prime? Derivative of the first, which is now product here. F double prime G plus F prime G prime plus now product here. G double prime F plus G prime F prime. And that is what? F double prime G plus 2 F prime G prime, this and this, plus G double prime F. So this is okay. I think now we are done with this, with section 3.3. Let me stop the recording. Thank you.